Hi, my name is Meredith Miller. I'm working with Professor Victor Lee in the Advanced Civil Engineering Materials Research Laboratory, or ACE-MRL, a part of the Civil and Environmental Engineering Department. I'll be going into my 4th year as a mechanical engineering student here at the University of Michigan. My summer undergraduate research project is to develop and test an engineered cementitious composite, or ECC, containing a phase change material, or PCM. ECC is a special concrete material containing plastic fibers, which give the material a far greater tensile strength and strain capacity than typical concrete. This unique ability can play an important role in preventing material failure during extreme stress situations, such as an earthquake. On the other hand, using PCM in building materials can help reduce the heating and cooling costs of a building. The theory behind this benefit is that when any material changes state, its temperature remains constant, such as when ice is melting. After reaching its melting point, all the heat inputted to the ice is going towards changing its state instead of raising its temperature. Now, instead of water, imagine a million droplets of wax with a melting point of around room temperature mixed into ECC. A room with this PCM-ECC material has the potential to maintain room temperature for longer. As animated, in both rooms, as the sun shines through the window, the temperature rises. But as the temperature reaches the melting point of the PCM wax, the temperature in the room with the PCM stays constant, while the room without the PCM continues to rise. Of course, in the room with the PCM, after all the wax has melted, the temperature will begin to rise again. By combining the behaviors of PCM and ECC, an energy-efficient, highly safe material can be developed, which is why samples of this material will be tested to determine its mechanical and thermal properties. Samples will undergo both a uniaxial tensile test to determine the tensile strength and strain capacity, and a compressive test to determine its compressive strength. Thermal testing will include the determination of thermal conductivity, or how easily heat can flow through the material, and specific heat capacity, or how much energy is required to raise the temperature of the material. Because of the behavior of the PCM, the specific heat capacity is dependent on temperature, so a custom testing apparatus will be built to record specific heat capacity versus temperature profile. The apparatus used can be seen in this slide. In the middle is the specimen. It is surrounded by 2 aluminum plates, which will be heated by the water distribution system on both sides of either plate. Thermistors in between the specimen and the plates, as well as heat flux sensors in the same location, will record data and allow the calculation of specific heat capacity. Together, all of these parameters will determine whether or not this material is a viable construction material and help to estimate the potential energy reduction if this material was used in a typical building. Thank you.